Welcome back to our classroom. Here we are going to discuss about Archimedes principle, right? So generally, what is Archimedes principle? Do you know swimming? No, right? Even though you are weight, but if you know swimming, you can float in that water, right? How? Yes. Let's see with a basic example. Have you seen ship? Yes. Can you able to see in ship in sea how much weight it is, but still it is float on the sea water. Why it happens? Yes, this is due to only through Archimedes principle, right? Yes, it's clear. Yes. So generally, what is Archimedes principle is a body is immersed either partially or fully. Okay, a body is immersed in a fluid either partially or fully. Then the upward force is exerted on that object. Okay, they experience some upward forces. That object receives some forces from that water. That is, we are saying that buoyant force. Yes, the upward force exerted by the liquid is called buoyancy force, right? Due to that, what will happen is that buoyancy force, right, that is equivalent to the weight of fluid which is displaced by the body. Yes, it's clear. Yes, have you able to understand what I am telling? So the statement is here: when a body is immersed fully or partially in a fluid, body experiences an upward force. How it becomes receive upward force? Due to the fluid, right? That is equal to the weight of the fluid displaced by it. Yes, that is called Archimedes principle. As in here, you know swimming, right? And you are going to jump into the water. What will happen? The water will get displaced, right? Yes, of course. So with respect to your weight, the displacement of water should be equal. That time we can use this Archimedes principle, right? The upward force, that buoyant force, is equal to the displacement of water by the body. By the body means me or you, right? You are going to jump into the water. That time you are acted as body. You are either immersed fully or partially you can, right? That time what will happen? You experience some force, upward force. What is that upward force? The upward force exerted by the fluid is called buoyant force. That buoyant force is equal to the displacement of water by the object. The weight of the displacement by the object, right? So here the statement. Here they are given one very good example. Assume here, let me take one small rubber band, okay, and for me right now I have this one only, right? So what I am going to do, assume here this is one is rubber band. In that rubber band I am going to tie one stone here, okay. So this is rubber band, right? Rubber band has a very good property, elasticity, right? If you are adding weight, what will happen? This rubber band will be elongated in air, right? The same thing I have did here. So this is a rubber band I am holding here and the weight is here. The elongation will be in air. That elongation will be more when compared to the setup is going to immerse partially or fully or in a fluid. That time what will happen? The same thing we are going to dip into the water or into the fluid. Initially partially we are doing, right? If you are doing partially, what will happen? This elongation gets reduces. Why? In the sense, this fluid exerted some force, that is called upthrust, right? Upthrust force on the object, right? So due to that, the object is displaced the water. The weight of the displaced water should be equal to that upthrust force. That time the elongation should be less. Still, if you are going deep, what will happen? The elongation becomes less. This is due to Archimedes principle, right? So what are the uses of arithmetic principle? So we can designing ships, submarines. Okay, even though the ships and submarines will have huge weight, but it can float in that sea water because of this arithmetic principle. So when a ship is immersed partially, okay, it's immersed partially only, right? Only the bottom of the ship is immersed in that, right, partially in a sea water. The boat experiences an upthrust force by the sea water that is equal to the weight of the fluid, the weight of the sea water displaced by the boat, ship. That's clear now? Yes, of course. I believe you. And submarines, I said. And lactometer. What is called lactometer and hydrometer? Yes. We have a lactometer and hydrometer. So we have some, just like when testing measurement we will have. So if you have placed that lactometer in that milk, what will happen? No one nowadays is selling their milk without mixing the water, right? Yes, we can identify the purity of the milk by using lactometer. Suppose if you are going to buying 1 liter of milk from the milkman, right? So in that milk, if you are testing it, in that lactometer, we are going to insert that lactometer in your milk. What will happen? After some time it attains equilibrium position, it will be take rest. Yes. How the doctor checking the thermometer either inside your mouth, right, or under the arms, right? So similarly, we are going to place in that lactometer into your milk. What will happen? The milk is a mixture of milk and water, right? Yes. Which one is more density, milk or water? Of course, milk is the density, more density when compared to water. So density high means it will go down. Density low means it will be in the top, right? Yes. So we can identify by using the lactometer how much amount of water they are adding in that pure milk. In that indication we will have in lactometer either 1/4 or 1/2. They will give some indication, right? How the measuring jar we will have. Similarly in lactometer they have given one line. So they are given one red line. That is if it comes to red line, that is a pure milk. Above the red line they are given as 1/4 or 1/2 or 3/4. That means for 1 liter they are mixing with 1/4 of liter. That is 250 ml they are mixing with that water. Or 1/2 comes 500 ml of water is mixed with water. Right? 1 liter of milk. Yes. And hydrometer also is a kind of checking a density of liquids. Right? Remember that the more dense fluid will go down and the less dense fluid is always float on the more dense liquid. Yes, and very good example, if you have any oil, right, in Gulf countries we have more number of oils, refinery process we have, right? In that places, if it is burned, what we should do? We should pour water? No, right? Because when compare oil is less dense, so it will float on that water surface. So if you are pouring in an oil, fire accident in an oil, what will happen? Definitely. So the oil will come up and water will go down, and firing will be continuously will firing in that. Yes, it's clear. I hope you understand well. Thank you. See you in the next video.